Okay, hello students. Last video that I made was 3.2 practice problems and I completed 1 through 8. So here I'm working through question number 8. So questions again similar. How do we know the end behavior of a polynomial? In this case, you can clearly see there is a cubic polynomial, and cubic polynomial the leading term here is plus x cubed, and because this is the degree and there is a plus sign, so the maximum, so the graph has to be down up. So this is how the shape will be down and up. So what that means is the question is, what is the end behavior as x approaches to positive infinity? How does the y behave? And you can see right here is this has to be the shape. Uh, so if I try, let me graph this, sketch this this way, and maybe we don't know exactly what are the zeros here. So I'm not worried about that part. What is important is the shape of the graph will be something like this, right? So all it means is that so it means as x approaches or becomes a very large positive number, that means plus infinity, the y value, that's why I say this point goes on increasing. See the y value, x and y here. So this y value is more. So it goes to plus infinity up. Um, so y value change to plus infinity. And on the left side, as x approaches towards the minus infinity, and that's what it says as x approaches to minus infinity, y approaches to the graph, the black graph goes all the way down, and that is minus infinity. So this is all the same. Problem is, so this one is 9b, where what's the difference between the one that we did and the one that is given here is you can see if you see the leading coefficient. So the leading coefficient here is, I mean, the leading term is minus 6x raised to 4. So this is the degree, which is an even number. So whenever the degree is even, it's always either parabola will be up, or maybe if it is quartic, so this is degree 2, this is 2, this is degree 4. Whenever it is like x squared positive, and this is like positive x raised to 4. But right now there's a minus. What does this minus do? Is flips the graph. Now this x raised to 4, instead of up, this will be down. So if I draw x-axis and the y-axis, so I'm gonna graph something like this. See, what does that mean is as x approaches to this side, as x approaches very large positive number, that means as x approaches to plus infinity, and you can see the graph, this graph goes down, that is minus infinity, means y value, the output, the independent variable will be minus infinity. But to the left side, as x approaches minus infinity, then the graph goes down, which is minus infinity. What it means is so let me write that is as x approaches uh, to a very large negative number, that is x is minus infinity here, and the output y value thing. So this output, the y value goes down, so this is minus infinity. I hope this makes sense to you. So let's go to the next. Okay, question number 10. Right now, you can see the this example, the leading term is half times x raised to 6. It means it is plus. It is plus plus half x raised to 6. So positive, right? Now this is 6. So remember, it is again the degree is even. Now what is this degree is even? 6, which is even number, means that means the graph, because there is 6 here, the graph will start from up and maybe it takes 5 turns, and then you can see 1, 2, 3, 4, 5. So the maximum turns could be 5, and it goes up plus infinity and up plus infinity. So I can easily uh, draw x-axis and y-axis like this, and maybe something like this. So it means it can cross maximum, it can have maximum 4 real zeros this way. The question is, did they ask you, so how does the graph look like? The behavior is asked. So that means as x approaches, and it is positive, right? So it has to be up, up. So as x approaches to very large positive value, the y approaches also goes up, see? So plus infinity. But the left side, as x approaches very large negative, that means x and I'm repeating this again and again, and because most of these problems is just checking on if student knows how to figure out what's the y output will be. So in this case, you can see it goes up, right? So that means it goes to plus infinity and you're done. The question is, how does the graph look like? The graph will look, so you are given 4 options at the bottom, maybe, and they may give you, or the question is, can we sketch this? So if you want to really sketch, you have to figure out what are the zeros, and also you need to know what are the zeros of what multiplicity. The one that is given, we can easily factorize this. So this can be factorized into, so you can see half is can be pulled outside, and x raised to 4 also, and this we can write out x, so it will be x squared and minus 4, because if you multiply half of this, you have to get this too, right? So it's going to be x squared minus 4. Now what does this mean is it is positive. It means it is plus half x raised to 4, and this is can be written as x squared minus 2 squared. Difference of square is x plus 2 and x minus 2, and then you have the 0. So this answer is also going to have plus 2 and minus 2. So the 3 zeros for this is x is, so you can see this means this can be 0 if x is 0. So the 3 zeros are the zeros of the function is, one is x is 4, and you can see, sorry, not x equals 4, x equals 0 here with the multiplicity. So this is 0, but what is the multiplicity? So the multiplicity is 4, because it's repeating 4 times. See this part? And that means that it is even. So another thing is this number is even. That means the graph will take a turn at that point, will take a turn. And this is x equals opposite of plus 2 is minus 2. So the multiplicity is 1, just once. Multiplicity is 1. That means it is odd. It means, what does it mean? The graph has to cross the x-axis, and x equals plus 2. So if you really want to sketch this, so how does it look like? So let's draw the black color x-axis and the y-axis. And now we know the 3 zeros are that, let's see, this is minus 2, and this is plus 2, and this is minus 2. Okay, and also this is another 0. So the question is, how does the graph look like? And because it is positive and it is up, up, both up, up, so I have to start. So I have to start somewhere here, up plus infinity. And remember, at minus 2, multiplicity is 1, so this graph crosses. So this has to cross. Somewhere it will take a turn. And then over here it flattens, because it is like, it is, so it's going to look at, let me use the color. So this graph will go, and then here it will flatten like this. See, it will flatten like this and takes a turn, and then somewhere it will take a turn again and it will cross like this. So this is how you need to sketch without, of course, you can plug in this desmos.com and check also the confirm. You can really check on your Nspire graphing calculator, the black calculator that I gave you is CX. You can check and you say it just looks like that. Means either you go to the right side, your input, as they become x large positive, or they become x very large negative. So in either side, the y output will be positive. I hope I made sense for this. Why the graph looks, the pink color graph is the graph of this function. Remember, I want to show what, instead of this whole thing, instead of if it was half x raised to 4 and minus 2, x square. Suppose how will that look like? The degree will be 4 here. So this may not flatten. It may go something like this. So it may not flatten here. May go this way and then this way. So it depends on. So the higher the multiplicity, the more it flattens at the point. So that's the understanding of this. In this question, see, there are a few things to be. If C is a zero of a polynomial, then what is PC, right? I just want to check with the help of, let's see, there is a graph, and I just want to use something like this, and there is a point here, and this is a parabola, right? And this graph, let's call this is a polynomial px, and we don't know. The way I have drawn it is like quadratic, but it has a zero, so it says C is a zero. That means let's imagine this plus 2 is a zero. If this is zero, what does it mean? It is when input is 2, the output is zero. That means whatever the polynomial is, when you plug in x equals 2, your output is zero. That's what that means. So this has to be zero. Now that means we can write x equals x equals 2 is a 0, right? We can subtract 2 and then get x minus 2 equals 0. It means this x minus 2 is a factor. So this is called factor. That's why I say x minus c is called a factor. So this will be factor of the polynomial. It means if I can write a px here, just a simple example is x squared minus 5x and let's say plus 6. And you can write this as x minus 3 and x plus 2, sorry, minus 2 and x minus 2. And you can see the zeros are 2. So this polynomial can be equal to 0. When is this equation is going to be 0? Either x is 2 or x is plus 3. So this could be minus 3. Sorry, this is, sorry, the way I have given both are, so in this case, the way I have given is 2 and 3. So 3 and 2. So this is 2 and let's see, this is 3 and the graph is something like this here. So it means if so the main thing what I'm trying to say is that x minus 2 is a factor. Now what is this? C is is a dash intercept, and you can see it is the x-intercept because if you cross this x-axis, it is the. So what does this basically means? This basically means it means if C, so if the graph goes through a point, let's say 2, it means the 2 is the axis. It is 2. 2 is the x-intercept of the graph. It's the graph. So the graph is like so. It crosses the x-axis. So that's also called the x-intercept of the graph. But 2 is also called is 0 of the polynomial px. So that's the difference between the two different ways to describe. 2 is a 0 of the polynomial, and 2 is the x-intercept of the graph of the polynomial. So this is the understanding of the value. The x value is 2 equals 6. So let's go to the next. Okay, now this question you need to uh, sketch, but before shit. Yeah. Now, there is another question right here is factor the polynomial. This is problem number 12, and use the factor to find a zero. So what do you do? This is so simple, right? In this case, you can see there's a minus 2. So let me make it bigger. 2x cubed minus x squared plus x. The first thing I'll do is there's a x which is everywhere in all the terms. So divide by minus x. So I'll do divide. Then what is the reason? Let's say divide by minus x. Now, if you divide by minus x, you have to also multiply minus x. So this means it is minus x, and this 2 negative will change to positive, and just 2 will remain. There's a 1x at the bottom, 3x is on top, so it will be a 2x squared. This negative and this negative change to positive, and this x will cross out with this, and so there will be only 1 left, and there's 1 minus a minus 1, and that's how you get, right? The next is we need to somehow write this as, so write down minus xs, and you have to have 2 more factors. So how do you factorize it? So there's a 2, and you can see the shortcut trick that I showed you is, if I want to factorize only this, let me do it right up there. So 2x squared plus x and minus 1. So I want to factorize it. So if there is a 2, write 2x, and then divide also by 2. And then multiply the 2 to minus 1, that gives you minus 2. And there's a minus. So you look up, the only factors of 2 is 1 times 2. And there's a minus, and you can see when you subtract, so when you subtract 1 from 2, there's a plus 1 here. That means the plus 1 has to be so this one, so 1 has to be negative. So this I don't have to. So this has to be minus 1, and the other one has to be plus 2. That's the only way you can get minus 2. And also, not that, if you combine this, you get plus 1, which is right here. So this is plus 1, right? So I'm going to use this minus 1 right here and this plus 2 right here. And then you can see this 2 crosses out this 2, and we get 2x minus 1 and x plus 1. So let's put it together. If you see at the bottom, there was a minus x here. So that minus x and this 2. So your px now will be in the factor form minus x. Now the x, I can put it like a x minus 0, and the other one is 2x minus 1, and then there is x minus 1. So what are the zeros? So the zeros are this one, because you can't, 0 does not have a sign, so I'll just put a 0. This one, opposite of minus 1 is plus 1, and because there is a 2 multiplied, so we divide by 2. And here it is x equals, the opposite of minus 1 is plus 1. And now let's sketch this. Now, because this is minus, see, the regular cubic, there is a 3, the degree is 3, the regular shape of the graph is down up, but because there is a negative, this shape will be start from down up and then goes down, so reflects, so flips. So this is what is going to happen, look like. So let me draw x-axis and the y-axis. So, and remember, the 0, this one, there is no constant, so that it is like plus 0. There is no number, so it has, so it does not, so it has to, so the 0 and the x-intercept is the same, so that's 0. Then there is half, so this is 1, and this is half, and then there is a 1 and half. There's one slight mistake I did. I think I messed up somewhere there. It should be 2x. Let me check what mistake I did. X minus 1. Go back and replay. I think I messed up. This should be plus 1 here. So this should be plus 1. So the opposite of plus 1 is minus 1. So this is minus 1. So how the shape will look like is, how do we start graphing this? We'll start from up. So it has to cross this one. So I'll start from here. So start from up, plus infinity goes down, crosses the minus 1. Then somewhere it will take a turn and goes through the 0. And then somewhere it will take a turn and also not, it won't go too much higher, but it will go somewhere here only, and So this will take, because it has to cross the half, right? So it will take somewhere here like this, and and this is how the shape will look like from minus infinity up to down. And you can figure out from the graph, whatever that you see, which one is the right choice. So the main thing is to see, can a student factorize? That's the goal. And after factorizing, can you identify which is the shape? And after that, you put the zeros on the x-axis, and then you start sketching by just knowing this graph. Find a polynomial function that has the given zero. So it says this is the most easiest. They already give us those two zeros. It means it crosses at this and it crosses at 3. So it is, they did give us the multiplicities, assuming that means the graph is quadratic, goes to this 0 and 1. So the factor will be, that means x equals 0. That means x minus 0 is one of the factor. And the second one is x equals 3. If you subtract 3, it is x minus 3 is also gives you 0. So the two factors are this, and you can create a polynomial by writing the factors x minus 0 and x minus 3, and you're done. But this can be written as x and x minus 3. You can also write it in standard form by using the distributive property and write x squared minus 3x, and that's how you create the function. I hope you get. When you look at this, it looks a little confusing. So I want to take an example. Let's say if it was f of x, instead of uh, the a, let me take it like minus 2, and instead of k should be greater than 1, can be 3, 4, 5. I'll just like put 4. So what does that basically means? It means x minus 2, x minus 2, x minus 2, x minus 2, and you can see this can become 0 only when x equals 2. So that means the 2 is repeated 4 times. So this one has a multiplicity. The 0, so the 0 of the function f of x is 2, okay, but with multiplicity 4. So that means if I write this yield, so yield bin gives you this gives you x equals 2 is a factor. So this is a repeated factor, repeated 0. So yields repeated 0 at x equals 2, and with multiplicity, whatever that 4. If this is 4, we say, okay, this is 2 with multiplicity 4. So that's what you have to figure out yourself. So I try to show you what is the meaning of this. Means 2 is a 0. It has a repeated 0, and but how many times? With multiplicity 4. Does that help? In this question, all you do is first factorize. So I can use the grouping method. See, I can do this and write down. In the first one, there's a x squared common, and I can write it as x plus 4. You can see if I multiply this two, you really get this part, right? In the second case, there is a minus 4. You can take common under distributive property. So this x will remain, and now this is minus changes to plus 4. And now what you see is you see the same factor, which is pink color factor, x plus 4 is multiplied to both the terms. So I'm going to use that. And what stays is this x squared. So that's x squared. And this minus 4. Okay? And you can use this 2 means 2 square. And you can replace this 4 by 2 square and use the difference of square formula. See? And that is like a square minus b square, which is a plus b and a minus b. So this whole thing now will turn to x plus 4, and this will be x minus 2, and this will be x plus 2. Only thing is, we did forget that. So this function gx is, if I want to make it want to know when is it going to be 0, so you do just write the opposite. The zeros are opposite of plus 4 is minus 4, opposite minus 2 is plus 2, and opposite of this is minus 2. That means on the number line you will see minus 4 is this, minus 2 is this one, and plus 2 is this. So this is the smallest one. This is the largest 0. So they are asking each one of them is repeated, has multiplicity. All three of them have odd multiplicity. So multiplicity here is 1, which is odd. So they may ask you, what is the multiplicity, even or odd? So in all these three cases, it is odd, and I hope that helps. Now, how do you sketch this? So one more question. Now that we know how the sketch look like, so let me take this off, and now that we know it is, these are the three, and now we can easily sketch, and it is a cubic function. So if it is a cubic function, it has to be like this because there is a plus x cube. The leading term is positive. So that means somewhere down I have to start graphing from minus infinity. So down up. So it will go up, takes a turn, goes through minus 4, takes a turn, passes through this. There is a minus 16 here. What does that? Minus 16 means the y the y-intercept. If I do like this, somewhere down here there's a minus 16 here. So this graph now, so this will go across, and maybe it goes through this point, and then it has to go to plus 2. So this is the sketch of the graph. So main thing, it is down and up. It has to go through this. It crosses. See, it crosses. It crosses. So it, because it has a multiplicity 1, so it looks like this way, and this way, and this way. And that's it. And I hope that helps. This question, they ask you to use a graphing utility. But my question is, do we even have to need, can we become the human calculator? Yes, we can. The first thing is, what are the zeros? So you need to figure out what are the zeros. So the zeros are always the opposite of plus 1, which is minus 1, but it is repeated. So here multiplicity is 2. It is 2, and it is even, so that graph has to touch. And the other zeros are opposite of minus 3 is plus 3, and the other one is right here, opposite of minus 9 is plus 9. And then because there's a 2, so you have to divide by 2, which is 4.5. So if I want to sketch this graph, so where is this minus 1? So this is minus 1, and this is 1, 2, 3, 4, 5. This is 4, so the point 4.5 is right here. Okay, and then also 3. So where is 3? So this is 3. Yeah, these are the main point where the graph has to cross. Now remember, minus 1 is with multiplicity 2. So now what is the degree for this? So the degree is, this is x square. So there's a 2. That means there is 2x square. It x square, there's one x here, there's another x. So together, so altogether it becomes, the degree is 4, because this is x plus 1, this is x minus 3. So I'm sure you know this part, because you just have to see how many. It means it is x plus 1 is multiplied twice. It means that's what it means. I just want to write one more time so that we really understand. And when you try to open this, so this x multiplies, and you get 2x raised to 4. So this is that degree. Your degree is 4, and it is positive. So that means the graph is up, up. So we need to sketch the graph that is up, up. Uh, let me this. So okay, let me start from up. So this is the minus 1, right? So it will uh, start from up, and then it will cross, because minus 1. I'm not going to start. I'm going to start here, because it touches, or it takes a turn at minus 1. So it touches like this, takes a turn, and then where does it cross the y-axis? If you really want to know that, also we can figure that out. So because when you multiply the constant, there is this 1 here, so that 1 multiplies. So this is minus 3, this is minus 9. When you multiply minus 3 and if you multiply all these numbers, you get 27, but then divide by 5. So 27, if you divide by 5 times 5, almost like 5 and something, which is 2. So 5 to 5th. So it means if I write 1, 2, 3, 4, and if I write goes up here. So 1, 2, 3, 4, 5, and somewhere here it has to cross. See? So the graph goes up. Okay, it goes through this and takes a turn, and then at 3 it has to cross because there's a multiplicity 1, and then takes a turn somewhere, and then that's wrong. And then takes a turn, and then it goes like this. So I hope that helps to understand how to become a human calculator. So you start from r plus infinity, then you take a turn at -1 because there's at -1 the multiplicity is even number 2, and then it goes through this thing, and I explain you how do you get it, and then this goes to plus infinity, and then we are done. Hope that helps. So if you see this question is, I think it is 17. I forgot. If you see this question, they give you the graph, and all they're asking is what is the x-intercept. If you look at it, x-intercept right here is 0. So x-intercept is where does the graph cross the x-axis? Clearly, it is at 0 and 2. So these are the x-intercept. This is a small one, and that is the larger one. That's the x. And if the question is asked, what is the y-intercept? You can see y-intercept also is y is 0. And the question is, what is the local maximum? So this is the new concept maybe. So local maximum is where do you have the peak? Like see, that's the maximum point. Uh, so this point, there is some, okay, this is 1, 1. If you see it is 1, 1. So that means this is maximum, but locally maximum, but in this case it is the maximum. You don't have anything. So sometime you may have something like this. You may have a graph. You may have a graph like this. See, so this will be, and there could be another one, a bigger one. So there are two maximum here, local maximum. This is point. This also is local maximum, but so this is the smaller one. This is the bigger one. So right now we have only one local maximum at x equals 1. Also to be noted that this one has a local maximum, but this one does not have local minimum or local minima. So I hope that clarifies. Or you can just say does not exist or does not exist. And here they still expect you to use the calculator. But I want to show you without calculator, how do you know how many local maxima and local minimum are there? And you can see there is a 3 at degree 3. What we can do is there's an x common, and you can write x, and this become x squared minus 3x, and then minus 5. Now you can see you can't break this. You can't write directly as two factors. You can check doesn't 1 times 5 is 5, and if you subtract 1 and 5 get 4, but there is a 3, so this does not help. So what you do is use the quadratic formula to figure out that, and you can say, okay, one of the 0 here will be x is 0, but then you have to this one to write down what are the other two factors. We can figure out directly. One of the factor is 0, that means x equals 0 is this is 1, 0. To figure out the other one, you write x squared minus 3x minus 5. You want to know when this is going to be 0. You can use this formula quadratic, b squared minus 4ac divided by 2a. And if you work this is 1, a is 1, b is minus 3, c is minus 5. And I'm going to write directly. You can check this out. You get plus or minus 29 divided by 2. And this 29 is almost like square root of 36 is 6, and square root of 25 is 5. So something like 5.5 maybe. Yeah, I'm just want to show it. So it's going to be plus or minus 5.5 approximately, not exactly. And it is like this will be 8.5. So क्या भैया? And if you subtract, this will be like minus 1. I'm not trying to exactly like if you subtract 5.5 with minus 2.5, and that will be like minus 1.5. Okay. The main thing is one of them is positive. Of course, you're supposed to use the graphing calculator. Okay, I'm trying to do manually. I'm not going to get a perfect answer. One of them is plus, and other one is that's the main thing. It basically means that this is how it is. It is a cubic, so it has to be something like this. It goes through this point, and one of them is, what is important is, one of them is positive, the other one is negative. That means uh, somewhere here maybe 4.5 and somewhere here is minus 1.5. The graph goes something like this because it is cubic, and there it is. So there is a one local maxima. So this is local maxima, and there's one local minimum. That's all they're asking. Graph this and check how many local maxima. So there's one local maxima and there is one local minimum. Or it could be also this tricks also. Suppose there was a, I'm just write x minus 2 and this was like 3. If you try to expand this is like x cube plus minus 3 to 6x square, and it is going to be plus 2 to so it's going to be, and then it's going to be 12x and going to be minus. So they may give it this way, and that just because it is a cubic. Now watch this fun. Now, just because it is a cubic, does it mean that it always has a local maximum and local minimum? Now if you try to show this, you can clearly see this is x minus 2 the whole cube, right? It means it is x minus 2 and x minus 2 and x minus 2. It means the 2 has a multiplicity 2. That means the graph, this is 2. That means the graph will be something like this. So minus 8. So crosses minus 8 because the y-intercept. And flattens at here because there is a 3 that is, so this one is like, and goes like so. There is no local maxima, and no local minimum. So this is how it tricks. So just because the polynomial given here, does it mean that it has to be like this? Does it mean it has a one local maximum, one local minimum? Or this is also called relative maximum point. This is local relative point, or local another local relative point. So the point I'm making is, yeah, you need to be very careful there, and this completes the all the problem that I just wanted to make sure you guys understand the conceptual concepts. Thank you so much for watching, and make sure you have to complete homework 3.2.